डियर स्टूडेंट्स अस्सलाम वालेकुम। अपने कोर्स के इस पार्ट में अब हम स्टार्ट करेंगे अब इस कोर्स का एक और एस्पेक्ट विच इज़ बेसिकली दी C++ बाइंडिंग। In the previous topics we have been covering the specification of the ODMG standard, and that was basically the recommendations by the ODMG obviously, and where mainly we have been studying the interfaces that were defined by the ODMG, and those interfaces are basically the components of the object model. That is, they define different components of the object model, and for them they defined interfaces. इसका मतलब ये हुआ कि if you use a particular component of the ODMG object model, what interface you would be having. And interface means के what type of operations you can perform on those components. For example, अगर आप देखें कि like on object, on class, on database, on data types, वगैरह वगैरह. So those were defined in the interfaces of different components. After that, they discussed, and that was in chapter I think 4. They discussed the ODL and OIF. Means they defined the statements or the commands how to create or define the objects in the ODMG standard, and also the object interchange format, that if you want to move, let's say, the objects, what should be the statement, what should be the format, and how you assign values to the attributes or to the relationships of an object. That was basically the specification that the ODMG standard defines in general. From this chapter, which is the chapter 5th of this book, and onward from this chapter, they have given the specification for the particular language binding. That is, they have defined the binding for the different programming languages. For example, here in this chapter, they have given binding for the C++, and in the following chapter, they have given bindings for the Smalltalk or for the Java. But in this course, we will only discuss the binding with the C++. This chapter describes basically the binding for the ODL and OML, that is the object definition language and object manipulation language. And it means that if we use the C++ in ODMS, then how should we define and how different objects, and how should we perform different operations in C++. And again, this is a general specification, because this specification, it just gives the logical specification of the structure of the things. It does not deal with the practical implementation. Why? Because if we see even the C++, there are different implementations, or you can say different compilers of the C++ provided by different vendors. So the exact implementation is basically defined by the particular compiler or particular vendor. So that is not mentioned in the standard. The standard basically gives us the logical structure, the specification of the things. So as far as the ODL is concerned, the object definition language, it gives us the general specification of how we'll define the objects and different components of the objects in the C++. See, they have differentiated or separated the definition or the specification in general, and then again the language specific. You'll see in this chapter that it does not vary too much from the general specification. That is, whatever they have given in the previous chapter, this discusses that in this specific focus of the C++, but it definitely matches or resembles what has been discussed before. So ODL basically, if you see, whenever you want to use a particular C++ compiler, then you have to find the library, the specific library that particular C++ compiler vendor would have provided for the ODMG or ODMS binding. So let's say if we're finding, let's say, C++ Microsoft, then we'll find a specific library that will basically pre-process the definition that will give for the ODMS objects definitions, and that library will transform this definition of the objects that we have given for the ODMS, and it will transform into the C++ you can say types, or into that particular format, and it would also deal with the implementation of that thing. So this is about the ODL. And again, as far as the OML is concerned, OML is also basically the language of that particular language, that particular compiler. For example, in case the C++ compiler, again, mostly the languages, the commands will be used of the C++ compiler, of the C++. But if there is some specific command for the OML, for example, for the retrieving, then again that has to be enforced by that library that we have just discussed. As I have told you that the C++ binding specification just describes the logical structure of the object definition or of the object manipulation. It does not deal with the implementation. However, in certain cases, it guides the, let's say, designer, or you can say it provides some assistance to the designer. So the designer can guide the compiler for certain aspects of the implementation. And this is provided in the form of physical pragmas that are not some separate statement or independent statements. Rather, they work sort of as special keywords in certain cases, let's say in some OML statements, that using those physical pragmas, the designer can guide the compiler to adopt a particular implementation. For example, let's say to create the cluster, for example, to store the objects in consecutive locations. So this type of minor support is provided in the standard for the physical implementation of the objects. Now, this was a bit of the background. Now, if we talk about the C++ binding, again, the way they first define the basic principles, the guiding principles that they have taken care while giving the specification of the things, same approach they have adopted here. They have given certain guiding principles that they have taken care while defining or while giving the C++ binding specification. And there are two major guiding principles. One is that the user using the C++ for the interaction with the ODMS, he should not have the feeling that he's dealing with two different things. That is, the developer or the user should not have the feeling that on this time, at this particular moment, I am working with the statements that are working with the, let's say, with the ODMS, and at this time I am using the statements that are working with the C++ working or objects. So dealing with the transient objects that we generally do in the C++, or dealing with the persistent object that we generally do in the case of ODMS, so user should have the same feelings. He should not have some different taste or feeling, or maybe not too much of learning for using the statements to manipulate the object from the ODMS. One. And second principle is, as far as the data types are concerned, most of the data types that are used in C++ in general, and the data types that we are using at a particular time for working with the ODMS, they should be quite similar. There should not be too much difference for the data types for the C++ in general and the data types for the ODMS. So it means that the basic philosophy is same, that the user should have the same feeling while working with the ODMS as he was having the feeling while he was working simple C++. So this was a basic guideline, and upon this basic guideline, they developed two features of it. One is that you should have the same or similar data types. And secondly, as far as the operations or the statements are concerned, they should also be similar. So ये तो था कि what was the basic guidelines. अब ये है कि यहाँ पे जब हम बात करते हैं C++ की, when we are working with C++ previously, before the ODMS concept or before this binding, we were obviously dealing with the objects. Objects का concept was already there, और जाहिर है कि तमाम जो object orientation है और मतलब जो objects की dealing है, that we have been doing before. लेकिन ये कि now again we are dealing with the objects, but इस दफ़ा there's a major difference. What? That now we are dealing with the persistent objects or persistent classes. The classes whose lifetime or whose existence carries on even after the execution or the termination of the program that created those objects. And this is the basic difference between the transient objects and the persistent objects. तो इस लिहाज से वो ये है कि when we talk about the persistent classes, so for the persistent classes, we can have both type of objects. We can have the transient objects of the persistent class and also the persistent object of the same class. So such classes for which we can have the persistent as well as the transient objects, they are called or they are termed as persistence capable or persistent capable classes. So in general, when they use the term the class in this chapter, they generally mean the persistent capable classes. However, at certain places, when we need to differentiate between the transient and the persistent capable classes, at that time they will use that specific term. Otherwise, when they use the term class, it means the persistence capable class. Now, another important concept that you will see throughout this chapter, and that is the smart pointer or the reference. The C++ binding has adopted this concept that they have defined a smart pointer concept to deal with the persistent capable classes. So you see a term D_ref. This is basically the smart pointer that they have used for dealing with the persistent capable classes. So from now on, we should be familiar and we should be clear about these two things. One is that persistent capable classes, and secondly the dref. This is the thing that is used wherever they are dealing with the persistent capable classes. If you see now on the screen, you can find two, for example, statement. One is that we are saying that dref, and then in angle brackets we have given professor, and then we have given prof p. Now this is basically a declaration where they are creating an object of the persistent capable class, and the name of the object is prof p. And next, on the next line, what you are saying is that you are basically calling a method of the professor class. For example, in this case, you see we say that prof p, which is basically the name of the smart pointer, and then we use the arrow notation and then get tenure. This is basically a method that has been defined in the professor class, which is, as I have mentioned, that persistent capable class, because C++ uses this arrow notation to access the components through the pointer. So same approach has been used here. So if you see this small code or these two lines, you will find that this is quite similar what you have been doing in the C++ before. And the only difference is that the new thing that you're saying is the dref, and that I have already explained to you. You should be familiar with that. Otherwise, the notation or the general the terminology would be quite similar to what you have been doing in the C++ already. So the mapping, as we have been discussing the C++ binding, it basically maps what we have defined or what we will define for the objects declaration in the program to the C++ compiler. So what does it involve basically? See, when we declare something, when we define something, because we are discussing the ODL, object definition language. So when we are defining a class, and I told you from class onward, from now on, when we say the term class, we mean the persistent capable class. So when we define a class, We obviously give the name of the attributes as we have been seeing in the C++ in general, and also we have seen it in the previous chapter of this specification. So what we will doing, we'll give the name of the class or the interface, and then we'll define different properties. And when we define a property, we give obviously the name of the property. Let's say it's attribute, or it is a relationship, or it is a method. So we give the name of the property, and then we give the type. So when we say the mapping, so whatever the type or the definition that will give for a persistent capable class, the mapping means that these types that we have defined for a persistent capable class, they would be transformed to the C++ its own types. For example, if we talk about the data types, the basic data types, one we have defined in the persistent capable class, so those types would be transformed into the types of the C++. Similarly, if we are done with the structure, with the array, with the list, with the set, with the array, with the bag, or with the namespace or the prefix, all these things that will define in the definition of an object of a class, the library that we have mentioned before, that we have discussed before, that library will map the types that we give in a class definition. That library will map those definitions to the definition or the classes or the types of the C++. So this is the basic approach that will be adopted for the implementation of the C++ binding. Now moving to the C++ ODL in particular. So when we say ODL, C++ ODL, it means that when we want to manipulate or access a database, what we'll do, we'll define the schema for that database. The schema will be defined in C++. So that will be basically the description of your schema. It's not very different from the routine C++ class definition. And so we'll not discuss it in too much detail. Only now we have the concept what is meant by the C++ binding or C++ mapping, and how it will be implemented. This is basically the concept that we need to be clear about at this stage. And rest of the things are quite similar as we have been doing already with the C++. The differences will be discussed in detail. For example, on your screen in your front, you see the definition of a class, professor. So this class is basically been defined, and it is inheriting from the basic object that has been already defined in the metadata of the ODMS. So this is it is inheriting from the object. And again, as I've told you before, that the D prefix has been adopted in this all specification in this chapter to show that here we are talking about something that is related with the ODMS thing. Here you see that we have defined different attributes of class professor, and if you see the types, they are all the usual types that you have already familiar with while doing the C++. मिसाल के तौर पर इसमें आप देखें the short, string, और ये सब चीज़ें इस्तेमाल हुई हैं, and all of them, they are the things that you are already familiar with, and there is no need to discuss them. And on the right side you are seeing the name of the attributes that are associated with the professor class. However, when you see the relationship that has been defined here, this is something that we are not in general familiar with while dealing with the C++ classes. So here it says D_rel, or the relationship, and also because it is dealing with the object, so it says ref, because we already discussed that whenever we need to access other object, we use this dref thing. So here it says D_rel, that shows the relationship, and then _ref means we are dealing or we are accessing some other object. Here you see the department and then _professor. Okay, now these two things we'll discuss later in this specification in this chapter, but at this time this is enough for you to know that this defines basically a relationship with another object. And then on the right side is given the department. The department is basically or DEPT is the name of this relationship. So this is enough to know at this time. Next, on the next line is another relationship, and in this case we say D_rel, which is basically the relationship, which is with some other class or some other objects. And here it says set. In the definition of previous relationship, it simply said ref. It means that this relationship, through this relationship, we will refer one object of another class or one other object. But when we say here the set, this means that again one object of this class, which will be the professor, we will be accessing, contacting, or it will be related with multiple objects of this other class. Just as case mein we have mentioned the student. So after that there's a given underscore advisor. I will discuss it later. And the name of the relationship is advisees. Means that this relationship stores that a professor advises different students. So a professor works as an advisor for different students, and that is stored as relationship in this class definition or for this object. Then after that we have defined the operation, and this is just sort of routine definition that we are familiar with. Basically the objective of this slide is to make it clear that the definition of the ODMS classes does not vary too much from the usual class definition that we are already familiar with while using the C++. I have highlighted the differences and I'll further explain those differences. Now, as far as the data types are concerned, here you can see the list of fixed line data types or the built-in data types. As you can see, we have short or long, and the D underscore prefix is basically given here just to show that this is for the ODMS purposes. And if you see your book, the chapter 5th, then it describes them in detail, but I can understand that there's no need to discuss them in detail. And after that, they are given the structured literal types. And we see that we have got string and then interval, date, time, timestamp, and structure. And again, all these things we have seen when we saw in chapter 2nd the interfaces for different things, and we have discussed these things in detail. Just as an example, I'll discuss just one structure here, and as I've told you that we have already discussed these things in the when we were discussing the interfaces of different things. So the string has been discussed here, which is a collection type, and this string has been implemented or is being defined purely to represent the situation when we want to store the string in the database. It's not for the transient objects here. So this is the, you can say, the interface for the string, and we have already discussed it, as I told you. And initially in this class definition, the D string, we see that we have got different constructors. It means that these are different ways, the way we can define the string. They're different. There are three different structures, mean that we can define string using these three different methods. Then there is a destructor for the string object, and after that there are different operations defined for the string. For example, initially there is a assignment or equal to operator that has been defined. Then again there is the star or dereference operator. All of them, they are basically different operators that have been overloaded for this string object. So this just a sort of revision of what we have already studied, and we studied it when we were discussing the metadata of different components of the ODMG object model, and we also discussed string there. And the same applies for the, let's say, date, for time, for timestamp, for interval. These are different, you can say, structures or structure types that we have already discussed. So the implementation of these things is quite similar to what we have discussed before in the specification. Just a little bit change when we add, for example, a prefix, or otherwise it's quite similar or quite same to what we have already discussed. So we'll not discuss these the rest of the structure types. However, we need to discuss a bit in detail the relationships, because this is the thing that we're not in general familiar with while using C++. So here you see different methods or different types of declaration for the relationship. For example, here you see there are three types we have given here. One is ref, one is set, and one is list. we already know that the difference between set and list is that set is a collection of components, list is also a collection of components, but difference is that the set is an unordered, or the collection of the objects where order does not matter. Whereas when we talk about the list is basically an ordered collection of objects. So all these three specifications, they contain d_rel. That means it is for the database, ODMS, and rel means के relationship. And when it says ref, it means that through this declaration of the relationship, we will be linking one object of this class with one object of another class. It means a one-to-one relationship. When we say set, it means that we are linking one object of this class with multiple objects of the other class. Likewise, when we say list, again, it means the same thing. If you see here, for example, this is the approach that the C++ binding adopts to declare a relationship. On the top, you see you define different constants. For example, you see basically there are string constants. When you say, means it's an array of constant, array of characters. It's a constant which is array of characters. So it is underscore department, underscore professors, then underscore advisor, underscore advisees, and similarly other constants. This approach has been recommended by the C++ binding. So how do we declare a relationship? Now, it depends upon the cardinality. Cardinality means it could be one-to-one, one-to-many, or many-to-many. So when it says drel means relationship, now after that we'll have either ref or set or list. I'm not sure yet about the bags, but let's say these three. So after that we have to give two things, two parameters. Now first one is the name of the class, with which this relationship is being established. Again, the name of the class with which this relationship is being established. For example, if you see on your screen, in the department class, we are defining a relationship. We said drel and then set means one department has got multiple professors. So that is why it says set here. And then in the angle brackets, first we give the name of the class with which this relationship is being established, and that is professor. And then after that, we see the name of the constant that we just defined. Because here, as the second value, we have to give the name of the attribute with which this relationship will be established, that particular attribute. So see, as we have discussed before, that establishing a relationship also establishes link between the objects. And for that, we have to place the values or the OIDs of the objects at a specific place. For example, in this case, when we say that one department has multiple professors, it means that when you create a department object, let's say we have got DID1, for example, department ID1, just an example OID. When we create this department, what we did that we got this OID. Now, we have multiple professors in one department. So when we create an instance of a professor, let's say we got an OID PID1, let's say. So on one side we have got one department which is DID1, and there we have got PID1. So if professor 1 that we just created works in the department 1, we have to link these two objects, and the relationship is the thing that is used to establish link between two objects. Now in this case, what happens that in the relationship that we are defining here, for example, here we are defining the drel set professor and underscore department. In this underscore department is a constant that contains the name of the attribute, name of the relationship in the professor class that will be used to establish link between these two. And the next is the name of this relationship, and the name of this relationship is professors. Now, professors is the name of relationship that is defined within this class in the department, and in the professor class, we define a relationship and we give name department, DEPT. This is the name of the relationship that is defined in the professor. So what happens that these two attributes, the professors in the department class and DEPT in the professor class, these two will be used to establish link between the objects of these two classes. So जैसे बात कर रहे थे कि let's say we have a professor PID1 who works in the DID1. So the professors will contain a reference to PID, professor 1, and the department DEPT in professor will contain DID1. So in this way, the link between these two has been established. Now, the thing is that in this case, the relationship is one-to-many. So what happens, that is why we have defined the professors as a set. It means that the professors can contain multiple references of different professors, whereas the department, the DPT in professor has been defined as ref. It means that one professor object will contain the reference of just one department. So this is how they implement one-to-many relationship, and this can be traversed simply if we just give the name of the relationship. The ODMS or the system will automatically give you the access to the corresponding objects. As you can see from here that when we define a relationship, first we give the name of the class with which this relationship is being established, and secondly we give the name of the relationship that will be used to establish the relationship. So rather than giving the name of that attribute directly, this is the approach that has been adopted here, that they define a constant here and then they put the value of the attribute in that constant. So that you can see that at the bottom they have given the values to two constants. One is the underscore department, and this is basically an array of characters, and it gets the value of DEPT, and this is placed in the department class when we define the relationship professors. And likewise we defined a constant underscore professors and we gave it a value of professors. So these values will be placed in the declaration of the relationship, and then they establish this link between the objects of these two classes. So we discussed the definition of a relationship within the department class, and likewise when we define the class professor, there we give the inverse definition of this relationship that basically links the objects of professor to the object of the department. Well, there is another relationship that has been defined in the professor class. As you can see, it again defines a one-to-many relationship with the students. So when we say that one professor advises multiple students, so here we have defined the relationship with a set of student. As you can see here, we have given student, which is basically the class with which this relationship has been established, and the underscore advisor is the name of the constant that will contain the name of that attribute which will be used to establish this relationship. And next is the name of the relationship in this class, which is advisees. So this is how you define a class, or you can say the entire schema for an object database in the C++. And when you compile this program, the library that we have been discussing before, that library will transform this declaration into the declaration that is compatible on one side with the C++ definition, and on the other side with the ODMS. ODMS will obviously accept this declaration, and this is how this schema will be created, and then you will use this schema in your program and the methods that you'll define within the classes. So in the ODL component of the C++ binding, we have seen that how a class is defined in the C++ binding, and the three main components of a class, which are the attributes, relationships, and methods, how they are declared and defined within the class. So we have seen the attributes example, we have seen the relationship example, but we have not seen yet the method. We have just seen the declaration or the signature of the method, but not the actual code for the method. That is basically the component of the OML, object manipulation language, that we are going to discuss next. Now, C++ OML. Again, here we'll see how the objects are manipulated using the C++ binding or C++. And when we say object is manipulated, it means that object is created, object is assigned values, object is accessed or retrieved, or object is deleted, updated, and all those operations. And again, a guiding principle is that when you're using the C++ for the manipulation of objects through an ODMS, then again a user should be quite comfortable with the previous knowledge or with the previous experience with of working with the C++. So it should not be too much different from the usual C++. Though again, this is the basic principle or the guiding principle behind designing the C++ OML specification. And the other thing is that when you are dealing with the ODMS, it's not necessary at that time you are dealing only with the persistent object, because this is the additional thing that you get when you are working with the ODMS. But obviously, persistent objects are not the only objects that you need to work with when building an ODMS application, because you might also need to work or to handle the transient objects as well. So when you're using the C++ binding or in this specification, they have made it sure that working with the transient objects and the persistent objects should not be very different. And moreover, you can intermix them. Like for example, we can specifically say here that when you are defining or dealing with a persistent object, you can refer or include a transient object as well within the persistent object. However, you have to keep this thing in mind, that when you move a persistent object in and out of the main memory, and that persistent object, if it contains a transient object, then you have to take care of the initialization or the you can say the values allocation to the transient object. Because see, when we talk about the persistent object, that persists over different the execution of the program. So इसका मतलब ये हुआ कि if you created a persistent object in one program or in one session or in one execution of the program, you close that program, the persistent object goes to the disk. The next time you execute that program, you get the same persistent object from the disk. That is okay, because the values of those attributes that were included within this persistent object, they were stored on the disk, and next time you access that. But if it contains a transient object, those values will not go to the disk along with the persistent values. So it means next time when you bring that persistent object into the RAM from the disk, and it contains a reference or it contains itself a transient object, you have to take care of this thing, that that transient object gets properly initialized. This is a technical point here. Now, when we talk about different operations that we can perform on the objects, first of all, we see the object creation. For the object creation, we use the new operator. And in front of your screen, you see different forms of this operator. For example, if you see the first one, they are basically the formats for different types of new operators, and here you can see the different forms. So if we see their examples, here you can see the examples. For example, first of all, you see d_database, and it has this is the type, and you are giving two names of the objects. Basically, they are pointers, which is your DB and my DB. These are two pointers, and these two pointers will be used to connect with the database. So supposingly that they have been initialized properly, then next you see the declarations of the different objects. First of all, you say dref again because this is a database thing, schedule, and temp schedule 1, new schedule. Here basically you are creating a transient object, okay, and the type of the object is schedule, and temp schedule 1 is the name of the object that is being created here, and new schedule is basically that statement that is creating an object of type schedule. And as I told you, this is a transient object. After that, you see another declaration, and which is dref and in the angle brackets professor on prof2 and new your db professor and professor. Here you see that this statement or this declaration creates a persistent object. Your DB is basically the connection with the database because you did not see this particular parameter to the new in the previous declaration, and that is why it was a transient object. But here you see a link with a database, which is the your DB. Then in the course is the professor, which is basically the name of the class of the object type. So professor is basically the class whose object is being created, and then professor again is the class name. So the one of them is basically the physical name of the class, and one is the logical name within this program. So prof2 is basically the name of the object here. In the next statement again, it is quite similar with the previous one when you say that dref of type student and student1 is the name of the object, do mydb and student. This is again an object of type student is being created, and the name of the object is student1. In the fourth declaration, again another persistent object is being created, اور یہاں پر یہ ہو رہا ہے کہ آپ نے یہ دیکھا کہ آپ نے یہاں پہ ڈیٹا کا نام دینے کی جگہ آپ نے آبجیکٹ کا نام دے دیا. اس سے یعنی مراد یہ ہے کہ آپ نے جو ٹائپ تو آپ نے اس پہ اسٹوڈنٹ کی دے دی کہ آپ نے جو اسٹوڈنٹ ٹائپ کا آبجیکٹ جو ہے وہ کریٹ کرنا ہے, لیکن اسٹوڈنٹ 1 دینے سے مطلب یہ ہے کہ آپ یہ چاہتے ہیں کہ آپ اس آبجیکٹ کو جو کہ یہاں یہ ہمارا اسٹوڈنٹ 2 ہے بیکاز اٹ از اے پرسسٹنٹ آبجیکٹ, تو آپ یہ چاہتے ہیں کہ اس کو آپ کریٹ کریں. آپ او ڈی ایم ایس کو یہ گائیڈ کر رہے ہیں کہ یو شوڈ کریٹ دس آبجیکٹ اسٹوڈنٹ 2 نیکسٹ ٹو دا اسٹوڈنٹ 1. اس کا مطلب ہے کہ یہ فزیکلی جیسے ہم نے کہا تھا فزیکل پریگماس, تو یہ بھی ایک اس کی ایگزامپل ہے کہ جہاں پہ آپ او ڈی ایم ایس کو تھوڑا سا گائیڈ کر رہے ہیں اباؤٹ دا فزیکل امپلیمنٹیشن اور پریکٹیکل امپلیمنٹیشن آف دا ڈیٹا بیس. اور اس کیس میں آپ اس کو یہ گائیڈ کر رہے ہیں کہ بھئی آپ نے جو اسٹوڈنٹ 2 ہے اس کو اسٹوڈنٹ 1 کے ساتھ اسٹور کرنا ہے. اب یہ تو ہو گیا تھا ہمارا آبجیکٹ کی کریشن. اگر فرض کیجئے ہم آبجیکٹ کو ہم چاہتے ہیں ڈیلیٹ کرنا, تو اس کے لیے ہمارے پاس ایک میتھڈ ہے جو کہ بیسیکلی ہے ڈیلیٹ آبجیکٹ. یہ ایک ممبر فنکشن ہے جو کہ بیسیکلی ڈی ریف کے اندر ڈیفائنڈ ہے, اس کو ہم آگے دیکھیں گے. تو یہ ممبر فنکشن اس کو آپ کال کریں گے, اور ظاہر ہے کہ جو یہ ڈیلیٹ آبجیکٹ ہے, ڈیلیٹ انڈرسکور آبجیکٹ, یہ کس آبجیکٹ کو ڈیلیٹ کرے گا. ظاہر ہے کہ جو آپ کا ڈیلیٹ آبجیکٹ ہے وہ ایک میتھڈ ہے, اور اس میتھڈ کو ظاہر ہے آپ کال کریں گے کسی آبجیکٹ کے تھرو. یہ ہمیں پتہ ہی ہے کہ جب ہم بات کرتے ہیں آبجیکٹ اورینٹیشن کی, تو جو اس کے میتھڈز ہوتے ہیں وہ ہم کال کرتے ہیں تھرو سم آبجیکٹ. تو اگر آپ دیکھیں کہ سلائڈ کے اوپر لاسٹ میں جو اسٹیٹمنٹ لکھی ہوئی ہے وچ از آبجیکٹ انڈرسکور ریف ڈاٹ ڈیلیٹ انڈرسکور آبجیکٹ. اب یہ ہے کہ آپ نے ڈی ریف کے ذریعے آپ نے ایک آبجیکٹ کریٹ کیا, اس کا نام تھا آبجیکٹ انڈرسکور ریف. تو آبجیکٹ انڈرسکور ریف از دا نیم آف دا آبجیکٹ جس کے اندر کے کسی آبجیکٹ کا ریفرنس ہوگا. تو جب بھی آپ ڈیلیٹ آبجیکٹ آپ میتھڈ کال کریں گے تو وہ آبجیکٹ ڈیلیٹ ہوگا جس کا کہ ریفرنس جو ہے وہ آبجیکٹ ریف کے اندر موجود ہے. اور ہم یہ بات کر رہے ہیں, ناٹ ٹاکنگ اباؤٹ دی میموری کی بات نہیں ہو رہی, بٹ دس از دی پرماننٹ ڈیلیشن. اٹ مینس کہ یعنی یہ جو آبجیکٹ ہے یہ آپ کا جو پرسسٹنٹ جو ہماری اسٹوریج ہے وہیں سے ڈیلیٹ ہو جائے گا. تو یہ میتھڈ آپ یوز کرتے ہیں ٹو ڈیلیٹ این آبجیکٹ. اب نیکسٹ ہمارے پاس جو ایشو ہے وہ یہ ہے کہ ہاؤ ٹو ماڈیفائی این آبجیکٹ, یہ آبجیکٹ کو ماڈیفائی کیسے کریں گے. تو اس میں یہ ہے کہ ہمیں پتہ ہے کہ جو اپروچ استعمال ہوتی ہے آبجیکٹ اورینٹیشن کے اندر وہ یہ ہے کہ وٹ ایور آپریشن یو وانٹ ٹو پرفارم آن این آبجیکٹ, آپ یہ کرتے ہیں اس کے لیے آپ ایک میتھڈ لکھتے ہیں, اس کے لیے آپ ایک فنکشن یا ممبر فنکشن لکھتے ہیں. تو یعنی جس وقت ہم اس کی بات کرتے ہیں, یعنی جب ہم بات کرتے ہیں آبجیکٹ ماڈیفیکیشن کی, اس سے بیسیکلی ہوگا یہ کہ آپ جس طرح سے پہلے کرتے رہے ہیں سی پلس پلس پروگرامنگ کے اندر کہ آپ آبجیکٹس کو یعنی ظاہر ہے کہ کریٹ کرتے ہیں، ان کو انیشلائز کرتے ہیں، پھر آپ ڈفرینٹ اس کے جو ممبر فنکشن لکھتے ہیں جو کہ اس آبجیکٹ کی ویلیو کو گیٹ کرتے ہیں، جیسے ہم گیٹر سیٹر کہتے ہیں، جن کے ذریعے کہ آپ کسی وقت بھی اس آبجیکٹ کے اس کی ویلیو چینج کر سکتے ہیں یا سیٹ کرتے ہیں. لیکن پریویسلی وی ہیو بین ڈیلنگ ود دی ٹرانزینٹ آبجیکٹس. اس کا مطلب یہ تھا کہ آپ وٹ ایور دا چینج یو ہیو بین ڈوئنگ دیٹ چینج کنسرنڈ اونلی دا ریم، یعنی جو آپ کا ریم میں آبجیکٹ موجود تھا اس پہ آپ نے چینج کیا کئی دفعہ، جتنی دفعہ مرضی چینج کریں، اور آپ کرتے کیا تھے کہ فار چینجنگ اے ویلیو یو ہیو ٹو کال دیٹ پرٹیکولر میتھڈ دیٹ از مینٹ فار دا چینجنگ دا ویلیو اور موڈیفائنگ دا ویلیو آف دا ایٹریبیوٹس آف دا آبجیکٹ. اب اس کیس میں جب ہم بات کرتے ہیں چینجز کی، تو دس change is not only for the transient one, rather we are talking about the change in the persistent object. اور یہ وہ چینج ہے جو کہ ظاہر ہے کہ ڈائریکٹلی تو اٹ از بینگ ڈن ان ریم، ظاہر ہے کہ جو بھی ڈیلنگ آپ کی ہوتی ہے وہ ریم کے اندر ہوتی ہے، لیکن الٹیمیٹلی دس چینج ہیز ٹو گو ٹو دا ڈسک ایز ویل. تو اس کے لیے یعنی آپ نے یعنی جو بیسک اپروچ وہ تو وہی رہے گی کہ یو ول رائٹ اے میتھڈ فار چینجنگ دا ویلیو آف دا آبجیکٹ، لیکن چونکہ اس چینج نے پرسسٹنٹ بھی ہونا ہے تو اس کا طریقہ یہ ہے کہ آپ او ڈی ایم ایس کو یہ انٹیمیٹ کریں گے that this persistent object is going to be changed یا value of this object is going to be changed یا this object is going to be modified. تو اس کے لیے ایک میتھڈ ہے جو کہ ہے mark underscore modified، یعنی جس آبجیکٹ کو آپ ماڈیفائی کرنا چاہتے ہیں اس آبجیکٹ کے تھرو آپ اس میتھڈ کو کال کریں گے. تو جو او ڈی ایم ایس ہے اسے یہ انٹیمیشن مل جائے گی کہ یہ آبجیکٹ جو ہے دس از گوئنگ ٹو بی ماڈیفائڈ. اب آپ کیا کریں کہ آپ وہ میتھڈ کال کر لیں، کیونکہ ظاہر ہے کہ آپ پاس آبجیکٹ ریم میں تو موجود ہے، آپ نے اس کو ایکسیس تو کر لیا ہوا نا، آپ نے اس کو ڈسک سے اٹھا کے آپ ریم میں لائے ہوئے ہیں. جب ریم میں اس کو لے آئے آپ نے اس کے ذریعے آپ نے یہ مارک ماڈیفائڈ جس کو آپ نے بتا بھی دیا. اب او ڈی ایم ایس از ریڈی کہ اٹ نوز کہ دس آبجیکٹ از گوئنگ ٹو بی چینج. اب آپ اس آبجیکٹ کے ذریعے ان میتھڈس کو کال کر لیں جن کے ذریعے کہ آپ نے اس کو ماڈیفائی کر لیں، میتھڈ کال کر لیں. اب جس وقت آپ اس ٹرانزیکشن کو کہ جو کہ ہماری ایکسیکیوٹ ہو رہی تھی، جب اس کو آپ کمٹ کریں گے تو جس آبجیکٹ کے اگینسٹ یا جس آبجیکٹ کے اگینسٹ آپ نے مارک ماڈیفائڈ کو کال کیا ہوا تھا وہ تمام آبجیکٹس آپ کے ماڈیفائی ہو جائیں گے. تو دس از دا اپروچ دیٹ یو اڈاپٹ ٹو ماڈیفائی دا ویلیو آف این آبجیکٹ. اس کے جو او ایم ایل کا جو بقیہ حصہ ہے وہ ہم پھر نیکسٹ ٹائم پڑھیں گے. اب میں آپ سے اجازت چاہوں گا. اللہ حافظ.